Did that actually make a loud noise?
No. It sounded like no. I'm deaf in that ear. I'm sick.
Oh yeah, that's loud. You're really deaf in that ear?
Yes. When I'm sick, I'm like deaf.
That's kind of loud.
I never heard that.
That's pretty loud. That's
Yeah, I'm
pretty
gonna
loud.
concentrate on what
I'm gonna do this to everybody.
That is loud. It's like an elephant.
Oh, I spelled it wrong.
What'd you spell wrong?
Boil.
What? How did
Boy!
I forgot the
Bowl.
word.
So you did bowl.
Pretty much. That's not that loud.
It is so loud. Jesus Christ, my Lord and Savior. Man.
Lord and Savior, amen.
Isn't it loud? Can I do it?
That's really funny. It's fun to do.
Yell. Yell. Oh my gosh.
Is this here better?
No. No, still sounds the same.
Ethan, are you just deaf in both
No,
ears?
yeah, pretty much.
How'd you hear that?
I don't know what my nose makes.
Not completely.
Breathe through your nose.
Deaf means you're completely
No.
deaf.
I can't, I'm kind of sick, so.
Scream. Miss Peterson
I
busted
hear it.
out her nose flute the other day.
Yeah.
We were literally like, oh, that's a cool flute. And then all of a sudden she was like, put it under her nose. I'm like, oh, okay, I'm done.
Was it a heckle?
No, it was literally a flute that she played with her nose.
So, let's just talk about some history. If we remember what we talked about yesterday, we talked about a Greek dude. What Greek dude did we talk about? Aristotle. Okay, Mr. Aristotle was real smart and thought that there were 4 basic elements. What were they?
Earth, water, fire, air.
Earth.
Wind, air, fire. No.
Wind, air.
Wind, air, fire,
Okay, just
Wind, air.
be careful. Earth,
Earth,
fire,
fire,
water, air.
air.
Okay? No. Earth, wind, earth, fire, water, air. Earth, fire, water, air.
It's the
If you
airbender.
say air and water too fast, then it might come out as like art
Where?
or air.
Water, air.
What air?
Air, water.
Okay.
Or art.
Okay? Robert Boyle, it's funny, I love how he writes this. Skeptical chemist. Look at how he writes chemist.
Boy. Old.
But that was before we wrote or defined chemistry or spelled chemistry the way that we spell it.
What's the spicy one?
You guys are still writing? Holy cow.
We were screaming in our ears with a tube.
That's true. Have you ever had tubes put in your ear? Just trying to let you know what it feels like.
You didn't put it in our ears. You just screamed in our ears.
Okay.
Hold on, I didn't scream.
You
I
yelled in our
just
ears.
talked.
What's a tube?
Well, so,
Which amplified sound, which made it sound like a scream.
fix your face.
Fix your tube.
My tooth?
Your tube.
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 Tuba.
Tube.
Fix your tuba.
Gotta go from fix your face to fix your tube.
Alright, are we done now?
No. Keep talking.
Everett, you done? You close to done? Okay, so Aristotle thought these random 4 things were made up of, were elements, it couldn't be broken down. And at that time, there was actually 9 elements that they knew that they used on a regular basis that they didn't know were elements, which was kind of ironic, right? Okay? Well, Boyle was like, no, this is not right. Okay, so he wrote the Skeptical Chemist saying, you know, Aristotle, that's not true. Did truth change here? No, an element was always an element. Just one's perspective of what an element was changed. More theological, deep theological discussions. Okay. So he rejected Aristotle's elements and defined an element as any substance that could not be decomposed into simpler substance. You are right, Mr. Boyle. You are right. Okay? And actually later, Mr. Antoine Lavoisier completely destroyed Aristotle's idea by what? So he actually broke up one of the things that Aristotle said was the most basic element.
Uh-huh.
Shattered. And you can't really break up fire. You could break apart or separate the parts of the air into different things. All right? So now we're going to take that, we're done with history now for a while.
Okay.
We're going to talk about some things on the periodic table. Yes,
Is
sir.
there another one, or is that the,
Another one what?
like, one that slide there? Is there another
I think that's it.
Alright.
Let's take a gander up at the little periodic table over there. A lot of symbols, huh?
Yeah.
Okay, it says our current periodic table, each symbol consists of a letter or two, or three. There's actually some that are three that haven't been really named yet.
Oh, no,
Unun Akium, 118. That's the like Latin name for 118 or something.
Oh.
no.
So what? So if you look up there, it says that all those symbols represent letters from the element's name. So Mr. Kramer, why in the world is lead PB then? Because I thought it had to be letters from the name.
From its Latin name.
From its Latin name, plumbing from your bumming. Right?
Latin name.
Plum bum.
Not because it's actual name.
Plum bum.
So,
That's the actual Latin name for lead. Plum bum. You think I'm just saying it for fun?
What should we call lead in Latin? Oh, I know, plum bum.
There it is.
Oh, that is the most beautiful word I've ever heard.
Yeah, plumbing from your bumming. Every time you drop off,
A load?
yeah. Every time you pinch a loaf, it goes into the lead pipes, plumbing from your bumming.
I always
A load.
stop eating it. It's so gross.
Yeah, right, because my hands are shaking.
I always wondered when I was eating how, like, if it was really super big, how it got down this small toilet bowl.
Oh
How it
my
got
god.
through the pipes.
Ethan! Shit!
Plunger, plumbing from the bumming.
But it,
Oh,
sometimes, yeah.
How big are your poops, Ethan?
Not mine, but there was
Every
one at
time
the
I
Walmart.
threw a clock.
Oh, that's gross.
Not
What do you
kidding.
say?
There was one at Walmart that
It was this big around.
What is it? It's a horse taking down?
I don't know if that person has some laxatives.
Well, laxatives would be the opposite effect.
Yeah.
Well,
He was a little constipated.
yeah,
Oh
maybe.
my goodness.
That would
He
hurt.
held it in for like
Yeah, it
a year,
would.
just-
That would hurt.
Well,
It came out
that
one
was
big
when I
chunk.
was really young and my mom still took me to the restrooms, and that was.
It was a woman. Oh, good guy. Stop.
Mom came out
Girls
like-
don't poop. We all know that.
Oh yeah, they do.
Girls don't. They don't poop. They don't fart. Doesn't happen.
Oh, they fart.
My mom.
They definitely.
She ever went to like
and she said no. Girls don't poop.
They fart.
No, they don't.
Yes, they do.
No, they don't.
Why
Oh
is
yes, they do.
I can
My
attest to
cousin
that.
farts. They smell terrible.
Okay. All right, we're a little bit off track here.
Hey, is
I
the
feel like this is a period.
Is the
Just
camera
a little bit
on?
off track. Yes,
Oh.
the camera's on. Hey, ladies and gentlemen, moms and dads, this is what physical science is like.
So just edit this part out.
Educational.
I'm blaming it on my delusions like this.
Yeah, okay. All right, so there are 4 of your elements that you have to know for your element quiz. Anybody make note cards?
I finished.
Oh, I gotta tell you guys this. I'm gonna sweeten the pot for the element quiz.
Okay.
If you create note cards for your element quiz, and you bring them to school on Monday, and you show me, I will give you a point of extra credit.
8 points.
Wait a minute.
1 point.
You have
To memorize the
That's like 1 million nano
Wait,
points,
is it just
Carly.
the 4?
Get with it.
No, all of,
Is
all,
our test on Monday?
no.
Okay. It just has
But
to
I
have
want
this.
you to do them so that you can use them to study between now and your quiz.
Okay.
So, did everybody hear me? 1 point of extra credit just for doing them. Guys, literally probably take you 7 minutes to make note cards on the
Yeah, but if
30.
you just write
The
NA
symbol.
and then
So, yeah, literally, guys, this is the,
Anybody
I'm
need
making-
note card?
I don't. I need no cards.
It's all your kids' note card.
yes, all of those on note cards.
I don't care.
I would cut the note cards in half. That might be, that way you're not wasting them.
Saving, yeah.
Okay? Everybody good? Ferrum,
Yeah.
natrium, argentum, and plumbum.
That's
That's
fun
fun
to
to
say.
say.
Is that a quiz?
Oh,
Why are you giving this big words,
Oh
big
my gosh.
I thought we were
paragraph?
talking about the
Yeah, big
science.
word, red.
Whoa!
Almost
That's a big
all
word right
our
there.
solids
I didn't
that
spell that, man. Characteristics is a really long word.
Hey, hey guys, let's go. Let's focus here. We've had our little fun. Let's get back on track. Ramp up the maturity a little bit here. The reason why I'm sitting down and not moving is because I don't feel good, so. I might be up screaming and flailing my arms, trying to get you guys to pay attention to something you probably don't care much about. Glad I remember that, because I totally created that yesterday. I forgot to tell you guys the extra credit thing. Oh shoot, I gotta get the vocab
You
sheet.
told us that they,
I did,
but
but
let 8th period be
I bet you more of you will do it.
We probably will.
Will you do it?
I think.
Guys, that is literally like, I hate giving out extra credit and I don't really ever do it.
I'm still looking at my grades. It's not like- I haven't seen
Any of your grades?
any of them. I lost my paper the first day I got it, so I haven't
You guys know what the periodic tables are arranged really quite magnificently. I had students in chemistry this year go, man, I remember when we talked about stuff in physical science, and it made no sense, and now that we're talking about it in chemistry, it's like everything's come to life. And I'm like, yes, it's because physical science is awful. Because all I do is just tell you vocab stuff and very, very low surfacey level stuff because I can't go any deeper. Remember when we were talking about electron structure? Now I said, I can't tell you how to, you just gotta know, do this. You'll figure out why later. It's really hard for me to teach this class because it's so basic. And you get to like the really cool things about how things really relate and how things work a lot more in chemistry. Depends. If you could take it as a sophomore, if you have permission from me. And typically you have to be advanced math to be able to fit it in your schedule, but not always the case. You will have to have an A in this class to be able to allow me to let you take take. I have made one exception or a couple exceptions for some kids that got some pluses, but I don't do that very often. Okay?
You don't.
All right, got it in?
Yeah.
All right, it says almost all naturally occurring elements are solids at room temperature. Okay, great. That would be helpful if we knew how to identify it was a solid at room temperature so we can figure out which ones are naturally occurring. Okay? And believe it or not, the colors on the periodic table have a meaning. Did you think that these guys were just random colors for just fun?
No, I mean,
I
I
thought
thought
they
they
were
were
sorted in
sorted.
a-
I actually thought it was the
that-
element, like
I'll be
the
honest.
state,
The
the
alpha
matter that it was, and I was right.
Okay? So the black guys up here, all the black elements, those guys are what at room temperature?
Solid.
Easy.
Okay.
Wait.
Solid.
Solids, yeah?
There's 4 colors up there.
Yeah, someone colored this in, it's not supposed to be that color.
I'm like, that was so weird. Why are they green?
Yeah, someone used like a Sharpie and put that in green.
Yeah, I was gonna say,
How
I
can
got
you
both.
start
So
with
is that
black?
supposed to be black?
No, these are supposed to not have any color, they're supposed to be hollowed out. That means they're radioactive and man-made.
Oh, made octane,
Yep.
whatever it is.
Yep, these guys don't just appear, they have to create them.
The southern and the blue, those 2 blue ones are the only.
Okay? Yep, so the 2 blue ones, which is really interesting, are the only liquids at room temperature,
Wow.
naturally. Okay, could I get like lead to be liquid lead? Yes, but I'd have to heat it up to a
That's
really
iron.
absurd. Oh wow, iron. Yep.
How you fail?
I was thinking plum bone, sorry, all the stuff we were talking about. Could I get carbon to be liquid carbon? Yes, I could do that, but it's not at room temperature. Make sense? Okay? And mercury is the thing I showed you guys, the little liquid heavy metal.
No,
Weird
broken
that
up,
it's-
evacuate.
Yep. Okay, and red
It was probably.
at room temperature means a what? What is red?
Yeah.
Gas. Okay? So if I ask you oxygen, no, let's not do that one's obvious. If I were to do chlorine, what is that at room temperature?
Liquid.
Gas.
Solid.
Chlorine?
Oh, solid, gas.
Chlorine's a gas.
Oh, it's a gas.
'Cause it's, look up there, what color is it?
Red.
Red.
Oh,
Cl.
So they put that gas in your pool?
Well, they
Or is that
put,
different type of chlorine?
That was like a powder they put in the pool and like dissolved.
yeah, so I'm guessing what it is it's a powder that's like not pure chlorine, it's some sort of chemically bound thing, and then when it gets in your water, it breaks apart and lets the chlorine get into your water. That would be my best guess, it's some sort of chemical reaction that's happening that allows, because you can't just, because chlorine naturally by itself is a gas form. So like if you're gonna get chlorine not in gas form, you're either gonna have to take chlorine gas and make it really cold, or you're gonna have to somehow have some chemical reaction where it's like table salt has chlorine in it. I'm not sure that's probably not what it's made up of, but you could have some chemical reaction with water that releases chlorine into your water and therefore does whatever it's supposed to do.
You said chlorine is,
Yep. Okay, you guys do need to, like I'm not telling you what all these are, you need to look them up. Okay? Yeah, they're all in your book, you can look them up on your phones. Okay? What does motto mean?
yeah.
Would know?
Singular.
One. Yep, singular, one. Okay, so we said mono means one. If I'm talking about one element, I'm just saying that, for example, neon can exist in nature as a lone neon atom. It doesn't have to bond with anything to be stable. Okay? And it is only this group 18, so please focus here. Group 18, the vertical column. These are the only guys that can exist in nature unbonded to something, stably. Okay? So all these guys exist as a lone atom. It doesn't need to bond to anything else to be stable. It already is stable. We'll talk about why later. Okay? Those are called the noble gases. Group 18. That's their name. It's the noble gas group. Diatomic. Have we talked? I feel like we talked about diatomic elements. We have? We didn't talk about the 7-on-7 rule? You don't remember that? Okay. Different class then. I talked about that so much that I don't know which class I'm talking about. I talked about it, which one I didn't. I don't want to start talking about this before you've got it in your notes. What do you think di means? Two. Okay, notice we're talking about monatomic elements, diatomic elements, so it's specifically referring to the same kind of element. That makes sense? Okay, we're not talking about. So here's what I mean by this. If I have carbon and oxygen bonded together, is that a diatomic element?
Yes.
No. They're not the same element. Okay? We would just call that a compound. Okay? This would also be called a compound because a compound is any two elements or more bonded together. But this is also called a diatomic element because it is one kind of element that is stable, bonding to itself to form two. Okay, does that make sense? The difference here is diatomic element has to be the same kind of element. I don't know, does it say that up here? Yeah, I would say it's right somewhere next to this that they have to be the same kind of element in order to be a diatomic element. Okay? Now, there is a rule, okay? There is a rule that we use to quickly identify them. There's actually only 8 of them that can exist in nature stably if they bonded themselves. Okay? I will never see chlorine by itself, like as in one chlorine atom. It's not stable that way, like neon is. Okay, everyone understand? Neon is stable by itself. It doesn't need to bond. Chlorine is not stable by itself, so it has to bond. But it can bond to itself to become stable. And there's only a small group of people that can bond to themselves to be stable. Okay? It's called the 7-on-7 rule. This should make this a lot easier for you to identify the diatomic guys. This is very important for later. Okay? So this is not something you want to forget. Okay? I call it the 7-on-7 rule. The reason why I call it the 7 on 7 rule is because I start with the atomic number 7. The first diatomic element is nitrogen. Okay? Then, if I were to draw a line through all of these elements that are diatomic, it would make the number 7. Like if I were to take this, I were to go, what number would that look like? A 7. And there are 7 of them. 1, 2, 3, 4, 5, 6, 7. Everyone see that? So these 7 guys here can exist stably as a diatomic element bonded to itself. Only those ones, and there's one other one, hydrogen. Okay, so technically that would be, it's a 7 on 7 rule plus hydrogen. Okay, but I have no way of putting that in between. Okay, does that make sense? There is no other guys that can bond with themselves to be stable. Only these 7, atomic number 7, shape of a 7, 7 of them, and hydrogen. So if I ask, is phosphorus a diatomic element? No. Okay? It cannot exist as phosphorus bonded to itself stably. Can't. Last one. Poly. What do you think poly means? Well, be more specific. No, it actually means 3 or more. Poly actually means many, technically. But in the context of what we are going to talk about, it's 3 or more. But notice, it's 3 or more of the same kind of element. Like something like this. That is not a polyatomic element. Why? Why is that not poly?
Because it's not just one.
It's not just what?
It's not a specific element. It's multiple.
There's multiple elements. Okay? Notice this, this, and that. Just a couple of examples. None of them have multiple elements, different elements. They're all the same element, just 3 or more times. Okay, so anytime you see 2 different elements, or 3 different elements, or 4 different elements, cannot be considered a mono, di, or polyatomic element anymore.